All right. Thank you, Aaron and Maxine, for the opportunity to join in here and talk a little bit about plant nutrition, fertilizer, and trying to maintain a healthy crop through providing the nutrients that are needed. Just sort of set the stage a little bit. I'm going to try to focus a lot on individual nutrients, what their role in the plant might be, and a lot about what the deficiencies of an individual nutrient might look like. Just to give credit here, this is a presentation Tatiana Sanchez, extension agent in Alachua County, and I have combined for putting this thing together for a number of different purposes and modified it here for today's class, and some of the information actually to Dr. Joe Kemble at Auburn University as well, some of his photographs. So before I get into the main part of the lesson, just want to kind of set the stage just a little bit here in terms of things that are necessary to really be able to put this whole program together. It probably will be no surprise to most of the people listening today that the recommendation is going to be to start off with a soil sample. Get a soil test to find out what the background level of various nutrients might be, and also to determine what the pH of that soil is as well. Depending on which state you're in, the university soil testing lab might also offer other components of the soil test for additional fees. That might include things like organic matter. Might be of interest to you, especially for those that might be trying to increase the organic matter over a period of time, and you want to take a periodic look at that. So we're going to be assuming that we have some knowledge about this soil before we get started, and so that we know how to best address meeting the nutrient needs. So the perspective that I'm going to be dealing with is primarily going to be on a relatively light sandy soil. And I realize that in situations where heavier clay soils are what you might be dealing with, that some of this perspective will change somewhat. As I go through, I'm going to speak about different fertilizer materials and different sources of fertilizer, how those can be applied to the garden area. And so I'm going to kind of work my way through those little by little as I touch on each of the nutrients. But I just want to give a sketch overview of the fertilizer, making sure that everybody is aware of what the fertilizer analysis on a bag or container of fertilizer would be. And so I'll use an example of a fertilizer analysis like 5, 10, 15. If those are the three numbers on the bag, it means that the first number is the percentage of nitrogen in that bag. The second number is the percentage of phosphorus, but more specifically, it's the percentage of phosphate which is the source of the phosphorus in that bag. And the third one is potassium, and also more specifically, the amount of potash or the percentage of potash that would be in that bag. So in the situations where you are buying a fertilizer, that number that's on the bag is a guaranteed analysis. So you should have some assurance that whatever that label says, it's regulated by typically the state departments of agriculture, and so that you have some assurance that what's on that label is in fact what's in that fertilizer. So with those few things as a background, I'd like to go ahead and get started in the details here. And this slide shows the all of the different nutrients that are required for plant growth. There's 16 of them on this page, and depending on if you are aware that there's nickel is being considered as an important one as well. So if nickel were to be included, then you would actually have a 17th one, and that's more recent work. I'm not going to worry about that detail here today, but typically traditionally we think of these 16 nutrients that are available that you see on the screen. The top group there, carbon, hydrogen, and oxygen, are not typically supplied in a fertilizer. These are supplied either through the air, carbon dioxide, which would be CO2, and water, H2O. So carbon, hydrogen, and oxygen are typically nutrients that are required by the plant, but not ones that we would think of as an actual fertilizer that we'd have to apply. The next group there, just underneath that top layer, would be a group of other macronutrients, and these are nutrients that are required in relatively large quantities in the plant. And when we do a dry ash analysis of a leaf, where the plant material is dried and then burned and then put in a machine that measures the amount of each of those nutrients in it. That's what happens when we send off a leaf analysis. The quantity of those nutrients that are considered macronutrients are typically measured in percentages. So it might be 3 or 4 or 5% nitrogen in that dry ash material. So they're in much higher quantities than in the micronutrients that I'm going to talk about here in just a moment. So you see nitrogen, N, P for phosphorus, and K for potassium. Also underneath that, in just a little bit smaller letters, would be calcium, magnesium, and sulfur. So those 6 are considered the macronutrients, and N, P, and K are typically required in just a little bit more than the calcium, magnesium, and sulfur. And I'll go through those individually as we go. The rest of them are considered micronutrients. They're still very important. They're essential for normal plant growth, but they're required in relatively small amounts within the plant. So when we measure these, we're measuring these not in percentages, we're measuring these in parts per million. So it's a magnitude much smaller than the macronutrients when we take those measurements. So things like Fe, which is iron, Zn, which is zinc, Mn, which is manganese, Cu is copper, B is boron, Mo is molybdenum, and Cl is chlorine. So which is chlorides. So those are the nutrients. We're not going to spend a lot of time on the first 3. We're going to focus on the macro and micronutrients from this point as we go forward. So these are, again, the macros. And the first one that I want to talk about is nitrogen. This is probably the one that is most aware by folks that are growing plants. Nitrogen is required in large amounts and tells on you pretty quickly if we get into a deficient state of nitrogen. So if the plant becomes deficient in nitrogen, you will typically see these characteristics that are listed there on the right-hand side. You'll see much slower growth, and the symptoms tend to be uniform across the leaves. The leaves will be generally smaller, lighter green in color, or under real severe situations may actually be pale or yellow, and can sometimes cause a plant to be stressed to the point where it will trigger early flowering or maybe even some leaf abscission or leaf drop. So nitrogen is important in a number of different processes within the plants, and important in the role of building amino acids, DNA and RNA, the nucleic acid group. But also, I think we typically think of nitrogen as an important part and role that it plays in chlorophyll. So when we don't have enough nitrogen, we lose that dark green color. So it's a really important one as the plants grow. A few little deficiency images here. Where up at the top, the pair of leaves there, the one on the left-hand side where it has the -N, it's much more pale. I would suggest that we note that in comparison to some of the other ones that you're going to see a little bit later, you tend to have uniform discoloration across the entire leaf. So the veins are not strikingly different than the area between the veins. So when I use the term interveinal, I'm talking about the leaf tissue in between the veins. So here, especially on the ones on the left there, you can see distinctly that there are veins, but the color does not stand out quite as much as we will in some of the later slides. The area on the plant that we would look for nitrogen deficiency would be the older leaves. And so I want to take this opportunity to have the next major important piece, and this is probably as much of importance as anything that I'm going to say in the detective role that you're going to play. Nutrients within the plant are either mobile or immobile. So nitrogen, as it notes on this slide, nitrogen is a mobile element, and that means that the plant can take nitrogen from the older, perhaps less important leaves and mobilize that nutrient and move it up to the newer growth that perhaps is somewhat more important. So within the plant, there are a number of elements that are mobile. Nitrogen is the first one. Potassium is another major one that is very mobile. And as a result of this, when the plant gets limited on this particular nutrient, it's going to move those nutrients out of the bottom leaves into the upper leaves. So the deficiency, therefore, is going to tend to be on the older growth. If you see yellowing and it's at the bottom of the plant, then we might consider nitrogen as one of those that could potentially be doing that. If you see yellowing up at the top of the plant, but the bottom leaves are still green, then that would not be typical of what we would expect with nitrogen. In other words, in that case, as the plant is growing, it's needing some element, but it cannot move it from the older leaves, and therefore the deficiency shows up in the upper new growth. So these first ones that I'm going to be talking about here that are macronutrients typically are mobile elements that have to be moved from, or can be moved from, the older leaves up to the newer leaves, and as a result the deficiency shows on the older leaves typically for nitrogen. This is a crop where nitrogen management is really striking in terms of the way that a crop, in this case tobacco, would be able to show the symptoms, and that's why I use this. As you look at the older leaves, they are very yellow, very pale. In the middle of the slide, in the middle part of the plant, there's sort of a transitional zone, and then when you go up into the top leaves, there's more green leaves there, healthier status of nitrogen. And so that's very typical of what you would see as a general pattern, although this is a very striking and severe case of nitrogen depletion from the older leaves, moving it up into the newer leaves. The second nutrient that I want to talk about is phosphorus, also a macronutrient. It has a few different roles in the plant, less important in the chlorophyll molecule, but still important in the structural part of the plant. I don't want to go too far into detail on those. I'm going to include that in the discussion here, as you'll be able to see on the left-hand side, and don't want to go too deep into that. Just as we go through here, you get the idea that all of these nutrients play some important role in the physiology of the plant. And if you think of the strength of a plant in terms of growing, think of it as a chain. All of that chain is equally important to other parts of the chain. So it's not that we can do without any of these. All of these nutrients that I'm going to discuss are important in that chain. Phosphorus is also a mobile element. We tend to think of phosphorus deficiency as also slowed growth, but we tend probably mostly to think about purpling. We have purple symptoms that are often associated with phosphorus. For those of us that are here in Florida, most soil sample results that come back will be high or very high or even pegged off of the top of the chart for phosphorus levels in our soils. So I'm located here in North Florida near the town of Live Oak, which is near the town of White Springs, where we mine phosphorus out of the soil. So this whole area up here, it's very rare to see a soil sample result that is low in phosphorus. So depending on where you are in the rest of the country, or the other parts of the state here would also likely be high in phosphorus, but other parts of the country might be a little bit different there. So we have lots of phosphorus in our soils, and it's actually pretty rare to see a phosphorus deficiency. And one of the situations where we would see that is under really cool conditions early in the season, when the plant is not able to pick up and utilize the phosphorus quite as much. But you typically would expect to see some kind of purpling associated with this. So here's some examples of what phosphorus deficiency would look like. I just would caution you a little bit that keep in mind that the plant has purple pigmentation in the background of the leaves. And a lot of times when we get deficient of things like nitrogen, you might see an increase in purpling just because that pigment shows up better. So I just caution you there, just because you see purpling doesn't mean that it's a phosphorus deficiency. If you see otherwise relatively good growth, normal growth, well into the season, it's probably not likely to be phosphorus. But again, think of purpling as the trigger there for phosphorus deficiency. The next, which is a big nutrient for us, is potassium. And it has different roles as well as important in water relations for sure. And this also is a mobile element, deficient on the older leaves. And you tend to have this transition of discoloration on the lower leaves. But the difference between this nutrient deficiency and nitrogen perhaps is that we tend to have the deficiency around the outer edges of the leaves more strikingly. So the one on the picture on the left is one that is severely deficient in potassium, and you see the discoloration around the outer part, almost burning or necrotic looking in really severe cases. The picture more in the center shows the deficiency that would be more typical in a mild case, where the outer perimeter of that leaf is exhibiting some symptoms there, and that's the way that potassium would look. In the case of those of you that are tomato growers, you might also see some internal problems like blotchy ripening, soft fruit that are sometimes associated with low potassium as well. So you can get some symptoms on the leaves, but it also, in the case of tomatoes, can also create problems in the fruit as well. The next nutrient is magnesium. We're still in the macronutrient category, so it's important in normal plant growth. Magnesium is also really important in chlorophyll, so we see a lot of yellowing that will occur when we're deficient here. The big difference with magnesium deficiency versus nitrogen deficiency would be this intervenal chlorosis. So here we see the veins staying strikingly green, and in between the veins, which is the intervenal area, being something that would be typical of magnesium. Both magnesium and nitrogen would be on the lower leaves, as well as potassium and phosphorus for that matter. But in this case, the thing that makes magnesium deficiency stand out more than others is this intervenal aspect of it. So hopefully that picture up in the upper left really sort of shows what's going on there. You would typically find this on the lower leaves, not on the new growth. Magnesium is something that we can, if it's just a magnesium deficiency, we can use something like Epsom salts that's readily available. You see the recommendation here. You can apply a couple of tablespoons of magnesium sulfate in a gallon of water and pour that around the base of the plant, and it's taken up very, very quickly in the case of magnesium deficiency, if there's magnesium deficiency that would occur. The other part that you should consider in dealing with magnesium deficiency over a long period of time is that if you're going to have a recommendation that's going to come back from the soil test to use lime to raise the pH, And here in Florida, most of our recommendations will trigger somewhere in the 5.7, 5.6, 5.8 range. Below that, except for acid-loving crops, we're gonna trigger a lime recommendation. If you use dolomite or dolomitic lime, that means that it has a little higher level of magnesium than regular calcitic lime that is more calcium. So dolomitic lime still has calcium in it, but it also supplies magnesium and is a good way to supply that. So if you have trouble with consistently having low magnesium levels, you may want to consider dolomitic lime as your liming source when you do that. Here's a member of the bean family that's showing this striking interveinal chlorosis. These larger leaves that you see in the forefront of this photograph are ones that are more deficient. The newer, smaller leaves on this plant are darker green, and so those are the ones that are showing the new growth. So this is a sign where this the soybean crop here was really deficient in magnesium early, and either they've corrected it or it's still in the process of being able to move this mobile element from the older leaves to the newer leaves, and therefore showing the symptoms on the older leaves. So that's what magnesium deficiency would look like there. Here it is also in grapes, and hopefully you can kind of see the main characteristic is that the veins are strikingly green, and in between the veins are yellow. I'll also point out that if we're trying to tell this from nitrogen, that the interveinal chlorosis would be the first hint. But if we're trying to tell this different from potassium deficiency, I would suggest that in this case, it's not just limited to the outer perimeter. It goes into the center. This interveinal chlorosis goes into the central part of the leaf, which hopefully will be a little detective hint that you'd be able to maybe tell the difference between magnesium and potassium deficiency. The next nutrient is calcium. Here in Florida, our irrigation water, at least in this part of the state, comes from a limestone aquifer underneath us, and there's a lot of calcium in our water, 70, 80 parts per million of calcium in our water here. So you probably want to know a little bit about the source of water wherever you might be to see if it's coming from a source that might be high in calcium. You can also have your water tested. A lot of times at a soil testing lab like ours, we'd be able to send it in as an irrigation type water sample, and it'll be able to tell us the nutrients that are included in that. But calcium, think of it as something that's really important in the cell wall and the building blocks of the cells. And this also is one that is going to show deficiency more on the new leaves. So this is going to be a case where the calcium is think of the tips of the plant, so the tips of the roots, and then also the newest part of the growth is where calcium deficiency is going to show up. And we have some very specific and well-known examples of the way that calcium works. Calcium is actually a little bit different than trying to think of it as a mobile or immobile element. Calcium is one that is picked up in the water stream and has to be transported in the water stream. So it's not very easily mobilized from different parts. So if you run out of water, you could also run out of calcium because the calcium has to be picked up by the plant roots in the water stream. So a lot of these other nutrients where you have more active transport across the root, calcium does not operate that way. So of all of the nutrient functions, I think of calcium as different than all of the other ones. So if you don't have a good root system, it's going to be hard to keep the plants with sufficient calcium. So on the picture on the left, you'll see that the newest growth there, all of the growth really, but especially that newest tip right in the center of all that is really struggling to keep growing. The slide on the right, I just mentioned that this is from a hydroponic type of system, so we can sort of see what the root structure looks like. And we need a lot of branching roots, fine hair roots, for good uptake of calcium in particular. So if we have nematodes or other kinds of situations where the root structure is not really healthy, that can really create some problems for us with calcium uptake. The other one that probably anybody that's grown tomatoes at some point in time has become familiar with blossom end rot. And blossom end rot is a nutrient deficiency. It is not a disease, although it certainly looks like a disease. So what happens in this case is that we call it blossom end rot because it typically manifests itself on the blossom end. You can even see where the dried up part of the flower would be on the tip of those tomatoes. That's what would be the blossom end. So as that fruit was, when the fruit was small, it ran out of calcium, or at least ran out of the availability of calcium within that fruit. And so the damage is done early, and as the tomato grows, it really expresses itself very strongly. So it does appear like a rot, and you can get a lot of secondary invasion in that sunken area that is that becomes visible as the as blossom end rot. I just want to kind of describe to you, one time this was explained to me, and it kind of hit home a little bit, that we typically, on fruiting crops like tomatoes and peppers, where we might know that we're likely to get blossom end rot. Those are two crops that are likely to end up with blossom end rot. But let's assume that we have the soil has the proper pH. There's a sufficient amount of calcium in the soil, so that it's not a calcium deficiency in the soil. But as the plant grows, let's say that it runs out of water, or we let it get a little bit too dry, and at that point in time, the plant cannot pick up enough calcium to get into that fruit. I mentioned earlier that calcium is picked up in the water stream. So, and this is the part that's kind of sunk in a little bit for me in understanding what's going on. The water is picked up by the roots, and then where does it go? It goes up the water stream, and then through evapotranspiration leaves it exits the plant through the leaves. Well, the pull or the drive for that water to be picked up then is driven by the evapotranspiration off of the leaves. So the tomato fruit does not have nearly as much evapotranspiration going on, and therefore is not as likely to pull a lot of that calcium in the water stream into the fruit. So if it becomes limiting, the leaves might still get plenty of calcium, but the fruit might in that instance be deficient, even if it's for a short period of time, because it's important in cell wall development. You get the collapse of those cells, and then later the symptom that is seen here. So what are the things that we can do to try to minimize the likelihood of that occurring? Well, we want to make sure that we provide an even water supply during the growing season, and I'm assuming that we've already taken care of the soil, and we know that there's plenty of calcium in the soil. The next thing that you can do to actually make this worse is to try to make that plant grow in way too much of a vigorous fashion. So if you push it hard with nitrogen, you get all this lush vegetative growth, therefore driving a lot more of the calcium in the water stream to that vigorous growth, and not enough of it that's going into the fruit. So you want to have sort of a steady rate of growth on the plant, and not try to do anything that gets it just way out of hand. If I were to try to say, okay, I want to show you that I can create blossom end rot in a tomato or pepper, what I would probably do is use something use a fertilizer in excessive amounts, and especially poultry manure, for instance, has a lot of nitrogen in it. It's a lot of it's readily available, but we constantly have a high rate of availability of nitrogen that I feel like I can, in many cases, create blossom end rot by that over vigorous growth, and the competition to get into that root also plays an impact there as well. So anyway, this is the more common way that we would see blossom end rot in the garden. In the case of leafy greens, and I work a lot with the hydroponic greenhouse industry, this is a very common disorder in our greenhouses when it gets really, really hot. And so there's a disorder known as tip burn, and the upper right-hand side is a pretty severe case of it. The lower left-hand side just has a little teeny bit of the tip burn on the leaves, not enough to really create much of a problem. And this was from a slide from some research that we were doing, where we would take ratings of the tip burn for each different variety that we were growing. So in this case, what happens, keep in mind that we have all this water that's picked up by the plant and then evaporated off of the leaves. Well, these larger exposed leaves are pulling more nitrogen, but the internal part of the plant, where they haven't even unfolded yet, are not pulling a lot because they're not really open and exposed to the sun, and therefore have lower levels of evapotranspiration. So we tend to see the nutrient deficiency with calcium, known as tip burn, in that center part of the head of, in this case, different types of lettuce. The next nutrient is sulfur. And I would say this is most similar to nitrogen in the way that it looks, except in the difference here is that the entire plant is going to show that lower level of green tissue. So this one sometimes is a little bit difficult to separate from nitrogen, but I would say that in the big difference is that in the case of sulfur, it's going to be more uniform up and down the entire plant. So that's what we see here. Just it's not strongly interveinal, it's just a sort of a general yellowing, but not limited only to the bottom leaves. Okay, the next group here, I'm going to go through a little more quickly, and I would say that this is where even for those of us that may have been more experienced with some of this nutritional stuff, that a lot of these are a lot more difficult. These are the micronutrients, so they're not required in real high quantities. And if you've got a nice rich soil that has a lot of organic matter, you might be a lot less likely, and maintaining a good pH, you may be less likely to see some of these kinds of nutrient deficiencies. But anyway, iron, zinc, manganese, copper, boron, molybdenum, and chlorides are the other ones that we're going to talk about here. So I first want to start with iron. And iron is also important in the chlorophyll molecule. We have a couple of striking symptoms with iron deficiency. One is that it's interveinal in its chlorosis, similar to what we saw in magnesium, except the location is different. So if you have interveinal chlorosis up at the top of the plant, we know, hopefully, let's think about that. If it's up at the top of the plant, it can't be magnesium because magnesium is a mobile element, but it could be a non-mobile element like iron. So we have interveinal chlorosis. And the other part for me when I see iron is that there's just a hint that it's not just yellow, it's white. So the chlorosis is strongly yellow. And in my case, I feel like I can target in, just go back to this other one here, picture, the picture on this slide that shows it's not just yellow, it's actually almost has a white hue to it. So it's going to be up on the newer leaves. The veins remain green. That would be a hint that you would be dealing with something that might likely be iron deficient. In the case of these micronutrients, sometimes if we know exactly which one it is, we can apply a micronutrient spray. Even you can buy a liquid source of iron, mix it in a hand pump sprayer, and spray iron on the plants, and the leaves will absorb these micronutrients in sufficient quantities to green that up. So that's one option that we have with these micros. The macronutrients, it's a little more difficult to do that because they're required in such large quantities that the leaves are really not made to pick up that amount. We almost have to deal with the macronutrients through the root system, whereas the micronutrients we might be able to spray and correct some of those deficiencies. But we also might see here that with iron, there may be something else going on where the pH might not be proper. If the pH gets too high, it may tie up the iron and make it less available. Zinc deficiency is something that let me just back up. Iron is something that I see pretty commonly. And then some of these other ones not so common. Zinc is one that I haven't really seen very frequently. And it tends to be sort of this leaf curling and a little bit of burning on the leaves. And so now for me, we're starting to get into all this stuff looks about the same, Bob. It's hard to tell. It's something going on in the newer leaves, and therefore it would at least be helpful that it might be one of these immobile micronutrients that's creating a problem. Manganese is the next one. It also has some intervenal nature to it up in the top part of the plant, required in pretty small quantities. There are also some foliar sprays that you could treat the manganese as well. Here we're back to a soybean, except instead of the lower leaves, this is the newer leaves that are intervenal in nature, and this is what zinc would look like in the case of a deficiency in beans. Here it is in avocado, sort of a similar thing. The big leaf there shows that intervenal nature, looks a little more splotchy, and then you can see the newest growth within that plant looks like it's going to show those symptoms even more strikingly. Copper, another one that I rarely see. In fact, a lot of times in our garden, we're using copper as a fungicide, and if we are, that copper is available to the plant. So if you are spraying copper as a bactericide or helping on the disease side, just keep in mind that copper is available to the plant as well. Boron is a little more important, especially in sandy soils. It's very leachable. So on our soil samples here at the center, it's not unusual at all to have pretty low levels of boron here because the sands just don't hold boron very, very well. Boron is going to be a little bit more important in the fruiting components of the plant. You can get some distortion and poorly formed flowers and fruit in the case of boron deficiency. It's also one that can be sprayed on as well. But I'm going to get back to this a little bit more detail. But I just want to kind of point out that when you're planting your garden and you're going to use a complete fertilizer, and let's say something like a 10-10-10 or 13-4-13, if you can get those with the micronutrients included, it's a really good way to just kind of keep a low level of those micronutrients available in the soil so that you don't become deficient in any particular one. And that certainly would be the case here with boron. Molybdenum is required in very, very small amounts, and I've never seen molybdenum deficiency except in our hydroponic system where we withhold it. And I've got a little container of about 4 ounces or 6 ounces of molybdenum. I've been using that for 30 years, a droplet or 2 at a time. So, and I've got enough for another 30 years for sure. But it's just required in very, very small concentrations, and also would be a crop that would be deficient up at the top. But to be honest with you, in a normal situation, I never remember seeing a leaf tissue sample come back where we were deficient in molybdenum. So just as a summary here, if I take all these pictures and all this sounds like they're all pretty similar on the micronutrients, that's because they're all pretty similar. And it's really hard for me to take a picture and feel really confident that it's either boron, manganese, copper, or molybdenum in the case of the ones that are shown here. So if you're having a consistent problem with this, the best way to resolve it is to send a leaf tissue analysis off for that drying and ashing so that they can come back and tell you which nutrient would be deficient. It's really the only way to do that. It might cost you $20 or $25 to do that. There's in some states, the soil testing lab might offer this as a service. The University of Florida is a research service, but not a clientele service. But there are many commercial labs out there that will do this for you. So one last piece here, certainly would be remiss if I didn't mention something in the case of pH and the impact that pH has on the availability of these nutrients. Some of you may have seen this particular table before, and the wider the band of each of those nutrients, the more available the nutrient is at that pH. So if you take nitrogen, for instance, it's pretty wide, anywhere between, say, 5.8 all the way up to 8.5. When you get way beyond that on the outer edges, then you see a narrowing of that, which means that the nitrogen is going to be available in a pretty wide range in the middle, but not as wide a range on the ends. If you look down in the middle, the dark brown one, which was iron, and I mentioned that if you see a consistency of iron deficiency, it might trigger you that, I may want to check the pH here, because as you see, iron is readily available at the lower pHs, but once you get up above around 7 or 7.5, the availability drops off pretty drastically. The same for manganese, same for copper, same for zinc. So in many cases, these micronutrients might be, if you're consistently having a problem with micronutrients and you look at this table, you might think, I wonder if I've got this pH just a little bit too high. So be careful. Don't just lime because. Make sure that you have a soil test that justifies the application of lime. If you overdo it with lime, then you can see where we can really run into some trouble here on especially our micronutrients. But if we look at that middle area there, something between, say, 6.0 or maybe just a little bit below that, up to maybe well into the 7 range, that most of these nutrients, all up and down the whole group of them there, are going to be pretty available. So we can maintain good growth at a little bit higher pH, but depending on the soil and the rest of the characteristics, I don't want to go too far with that comment, but somewhere in that range of 6 to 7, obviously you can see where it's going to be a pretty safe deal in terms of the availability of all of these nutrients. But the main point here is that the availability is definitely impacted by extremes in pH. So you want to keep a close eye on that every year, do a soil test to follow up and see where you are. Keep in mind that when you do apply lime, that it doesn't act instantly. Even if you incorporate it into the soil with a rototiller, it takes time for that lime to dissolve and do that neutralization. So you can't expect it to do its job if you start out just before you plant and incorporate lime. You need to get the lime out well in advance of your planting season. So Aaron, I'll pause there, and I'd be happy to answer any questions or any follow-up pieces that you know we need to discuss.
Okay, if anybody has any questions, if you would, you can go ahead and put that in the chat box now. We haven't gotten any through the presentation, so.
Okay. Well, while people might be thinking about a question, then let me just a couple of other things. I mentioned earlier that the basis here in Florida, most of our soils are pretty sandy until you get out some, there's parts of the state that are not, but most of the state we're dealing with sandy soils. And here where I am along the Suwannee River, these are deep sands, and we have very low organic matter. In fact, our organic matter here might be less than 1%. And that plays a role in the ability of that soil to maintain levels of nutrients. So especially those that are highly leachable, which would include things like nitrogen, potassium, magnesium, boron, for instance. Those tend to be nutrients that we really need to manage because they're just not held very tightly in our sandy soils. If you have high organic matter or clay soils, you're less likely to run into this problem as frequently as we would on our sands. So, and in fact, in the case of our sands, we're more worried about losing nutrients through the soil profile, whereas in a heavier soil, you're probably more worried about having those nutrients run off of the soil not run through the soil. So there's a lot of really important differences in terms of the way that the nutrients perform.
Okay, so we did get some questions come in. Is there a common household way to add potassium to the soil?
Well, a common household way, I mean, the most common way would be to use a fertilizer that has potassium in it. So the example that I was using earlier, 5, 10, 15, it's got more potassium than anything else in the soil. If you're looking at things like wood ash, there's some other types of supplements that can be used. Wood ash has a lot of potash in it. I would also say that a lot of the animal waste materials, so if you're using composted animal waste, especially poultry manure, that's very high in potash. So most of our animal wastes are going to have, yes, they're going to have nitrogen, but they're also going to have phosphorus and potassium, in many cases a lot of micronutrients. So I think that using the correct amount of an animal waste, composted animal waste, or making your own compost, you would also be able to bring potassium in. But I think the main thing for me would be to take a soil test, and then if it's low in potassium, maybe consider a higher source of potassium in the fertilizer that you would add.
Do you recommend using pH test kits sold at stores?
I would just say that the level of investment that you're going to put into that is going to be the result. If it's really, really cheap, I'm not sure that I put a lot of faith in that. The other thing that a pH test kit does not do, that a soil test will do, is that it takes into consideration these other factors that are involved in the soil. So you're going to get a much more accurate recommendation of how much lime to put out through a regular soil testing lab. So I would say, it's not that I don't recommend them. I would just say don't expect too much from a $5 kit that you're probably going to get out of it what you invest in it. But the thing there is that the pH is not just simple. There's a lot that goes on, whether it's a carbonate or bicarbonate. There's the amount of organic matter in the soil. So there's a number of other factors that go into a lime recommendation, and you can't get that deep level of detail from just a regular pH meter or the inexpensive ones.
Sure. Can you explain the relationship between pH and the concentration of ions mentioned on the last slide?
Yeah, so the pH is just a measure of the hydrogen ion, which is a measurement of that that gives it that pH. So the higher level of that, the more acidic the soil is going to be. I don't know if that's what the pH is. It's the measurement of that ion.
What could cause stunted growth throughout? A plant is hardly growing any leaves.
Well, for today, it's a fertilizer relation, but there's a number of things that come to mind there, that there could be something entirely different than a nutrition problem. If it's an individual plant, there could be plant viruses. There could be nematodes that are not allowing the plant to grow properly. If the plant is a single plant within a row where the other ones are more healthy, I would say that oftentimes means that it's probably not nutritional. If you have 10 tomato plants and one of them is really stunted and not growing at all, but all the other ones are doing pretty well, the soil doesn't change that much from a few inches away. But if the whole plant is not growing and you think it is something related to nitrogen, then related to the fertility, then I would say that's the importance of having a soil test, so that you kind of see those things coming. So I don't know, there's a multitude of things that can keep a plant from growing. But I would say that in a garden situation, that if it's If it's related to plant nutrition, you would tend to have symptoms among a group of plants and not just a single plant that stands out.
If we're container gardening our vegetables, what are the recommendations for soil and adding manure, organic fertilizer mix? They're growing root vegetables, tomatoes, and herbs.
Okay, so the container would have some type of a soil-less media in it, I'm going to assume. A lot of times when we take native soil and put it in a container, it doesn't drain very well. So I'm going to say that I'm going to assume that if you're talking about a container that we've got a peat mix or peat and pine bark or peat perlite pine bark, some kind of soil-less medium. And one of the things that we have used here in our in our soilless media that is readily available at most home garden centers would be something like a Miracle Grow. The standard Miracle Grow that most of the time I see in the stores would be it's 24-8-16. Okay, so it's got 24% nitrogen, 8% phosphorus, 16% potassium. So that's a pretty complete material. And the professional grade has all the micronutrients in it as well, except calcium and sulfur. So what we found that works really well here is that particular professional grade of a material like Miracle Grow. It could be other commercial brands, but something that is the professional grade that has the micronutrients. And then we use Epsom salts to supplement it. So it would be something like 1.5 teaspoons per gallon of the Miracle Grow, and then about 1 teaspoon per gallon of the Epsom salts. And then we're getting the calcium from our water. And so that gives us everything that we need to fertilize with in that situation. Was there part of it, Aaron, that mentioned something about manures or something?
Yeah, so here's a follow-up question comment. They were told for container gardening that I should layer soil, manure, organic fertilizer. They're using a 4-4-4. Should they be concerned with the pH levels and nutrient levels, given watering would leach out some of the nutrients?
Yeah, well, you don't want to leach on purpose. I mean, in a container, you want to be able to time the irrigation so that you're not leaching out of the bottom. The layering is not something that would be necessary. However, I think one of the main points that I would want to make here is if it's fresh animal waste, then you have a very serious food safety issue. So if it's fresh animal waste, it should not be used within a long period of time between the time of application and the time of harvest. So you want to be careful about using fresh animal waste. And I'll use chicken manure as an instance. That is almost always fresh chicken manure is going to be loaded with E. coli and salmonella. So you have to be careful that. I'm not sure if that's why they would have been layering it to try to separate it from the top of the bed, but in either case, it's a bad idea for fresh animal waste, unless you leave this waiting period between the time you apply it and the time that you harvest. However, if that material is properly composted, or if you're buying a commercial animal waste product, and there's a number of different animal wastes that are composted and pelletized throughout the area. And so those are typically, they are using a composted animal waste, but it also goes through a heating process when it's in its final form and pelletized. So it has gone through this food safety step that that material would not have the risk. By going through that heating and pelletizing process, it eliminates the E. coli and salmonella. So I think the main point I would want everybody to take away with is be very careful if you're using fresh animal waste as a source of nutrients. Go through a composting process or buy a commercially available product that has already gone through that composting process. The other thing, we oftentimes think of animal waste or maybe promoted as a slow release fertilizer. And I mean, there are parts of it that are slower to release, but most of those products are fully ready to go with a large percentage of the material. So like I think you mentioned 444, you know, in that situation, at least 50% of that material is probably available as soon as it becomes solubilized. So be careful with the rates there. Don't assume that it's totally safe no matter what you do because it's slow release. Don't get caught into that. I don't know if that addresses that sufficiently, Aaron, or not.
Okay. I know it's 12 o'clock and some people may have to jump off. I did want to mention that we did record this, and it'll be on the YouTube channel. I did put the link in the chat box. And then if you are a Victory Garden community member, you have access to the PowerPoints. We'll be putting those up in the Canvas module as well. But we do have a couple more questions and we'll keep going with those, Bob, if you're okay with that. Blossom end rot in watermelon. They applied calcium citrate. When should they reapply?
Okay. It's on the end of a watermelon, you can get something that will shrivel and begin to decay at the end of the fruit that it might be blossom end rot. But in my experience with watermelons, blossom end rot is not a real common situation. However, poor pollination is a problem. So you have the female flower with the baby female watermelon on there, and if the honeybee transfers the pollen from the male to the female and you get adequate pollination, then the watermelon will expand from that point and become a normal watermelon. If the pollination is not complete, then that end of it will shrivel and go no further if it's not completely pollinated. And the watermelon plant will put out many more female flowers than what it can support. So when it gets loaded up with 3 or 4 watermelons on it, it will start aborting those next ones that would have otherwise set. So I just want to caution that it may or may not be blossom end rot. If you have a big watermelon that has gone through that and then rots at the end of the watermelon, and let's say you have a watermelon that's the size of a quart jar, then you would assume that, okay, this got pollinated sufficiently. And in that case, the calcium may have been deficient and you end up with blossom end rot in watermelons. But I'm just saying that it's not a real common thing in watermelons. So back to the question, how frequently you need to be able to supply a constant supply of calcium. So if you also need to remember that it's important that it's taken up in the water stream. So you can't let the plant get drought. You have to supply that. I would say if it is a true deficiency, you'd have to apply that at least once or twice a week to make sure that you have sufficient calcium. And you'd also have to make sure that you've got adequate water so that that calcium can be picked up.
Thank you. How would a water softener source affect nutrients?
Yeah, it destroys it. So the water softener typically will take calcium out of the water and replace it with sodium. So you end up with the softened water is going to be void of calcium and is going to have high levels of sodium that are going to be toxic to a plant. And I'll just share with you a little story that my daughter-in-law wanted to do some hydroponic gardening on their patio. And so we set up the soilless media that we had just talked about a minute ago. And they followed the father-in-law's recipe with the Miracle Grow and the Epsom salts and blah, blah, blah. And things were going very, very poorly. And so I had not considered that, do you have a water softener? And then that was the culprit. So I actually took a water test of the before and after. And so water softeners are really a bad deal for vegetable production, especially if you're in some type of soilless culture. It might be a little more tolerant in a regular soil, but if you're going to use water, you need to figure out how to get the water to the plants before the softener.
All right, next one. Is there any good references? You know how you kind of went through each of the deficiencies. Do you know of a reference that they could either purchase or find online perhaps that kind of does the same thing for vegetable gardens or vegetables?
I'm not sure that I'm familiar with what might be good on the garden side of things there. Does the Florida guide have much of that in that? The garden
No
guide?
pictures.
What's that?
Not pictures.
Yeah.
Which is probably what they're looking for. I mean, that's what I like anyway.
Yeah.
Something to work on.
Yeah, it sounds like obvious good idea there. I mean, it's easy to if you think you know what you're looking for, you can get a lot of pictures with the Google search, but in terms of a specific publication for crop nutrient analysis, I'm sure there are some, but off the top of my head, I'm not prepared to answer that. Maybe I can follow up with that later, Aaron, and get that information back to them.
Somebody said they like the book, What's Wrong with My Plant?
Ah.
I know we do have a tomato and pepper ID card deck. The IFAS bookstore.
Yeah.
That might, I'm not sure if they have nutrient deficiencies in there, but it does have some of that information. Okay. Why is it recommended to use compost instead of simply to use fertilizer, which contains most macro and micronutrients?
Yeah, either one are fine. I think some of the questions were more. I took it that there was an interest in trying to stay away in some questions of stay away from a commercial fertilizer, and that would lead you to having to depend on composted materials. So either one of them would be fine sources. Commercial fertilizer that meets the needs of the plant, or a composted material, either one would be fine. Did not intend to portray a preference of one versus the other, but I do think it ends up being, it's a personal preference. If somebody doesn't want to use the commercial fertilizer, then that leads to dependence upon the more of the composted materials.
Somebody has a parsley plant in its second year and is now completely yellow at the base. What deficiency would this be? Nitrogen? No other issues?
Well, if it's pretty striking, and it's at the bottom of the leaves, if we go back through the detective work and it's just yellow and the whole leaf is yellow, the nitrogen would be the first guess. But I'm hoping that maybe through this class that we can think through the detective work. If we look closely at parsley and say the whole leaf is yellow, it's on the older leaves, then it would most likely be nitrogen. If the older leaves are yellow but limited around the perimeter of the leaf, then maybe potassium would be more likely. And then the final one would be if there's intraveinal chlorosis, then it wouldn't be either one of those. It might be magnesium. So hopefully going through the pictures and trying to match up what's going on there. If it's just general yellowing on the older leaves, then nitrogen would certainly be a good place to start. And when you think about those kinds of situations, nitrogen and potassium are required in huge quantities. So they oftentimes are the first things that become deficient, nitrogen and potassium.
Somebody's asking, is it possible to have a bum plant? So just one that doesn't perform, grow, bloom, or produce as well as the others, even if they were bought at the same time and planted in the same place in the same bed?
Yeah, absolutely. You get, in many cases, genetic variability. You might have something that was an infection or something that occurred, an insect transmitted virus. I'll just use that as an example to think through that. You got a pack of 6 tomato plants and you get a thrips in Florida that lands on it and starts feeding and transmits tomato spotted wilt, but that's the only plant that it feeds on of that 6, then you certainly could have an individual plant that would not perform as well as the other 5. And you do have genetic variability. If it's an open pollinated type of variety, you tend to get more variability. The hybrids tend to be more uniform. But if it's a real dud, then it could be it could be something genetic. It could be an insect or a virus or plant disease that's been a problem.
Sure. Some people put a couple authors and books in the chat if you want to see that for references. That might be helpful. Somebody also mentioned that compost also retains water and improves soil structure for the roots. And then we will, let's see, we're going to have 2 more questions, and then anything else, if you have any more questions, we can certainly get those to Bob and answer those. But we'll finish with these 2. So what is the key to distinguish between nutrient deficiencies and some diseases? That's a tough one.
Yeah. You do get a lot of mimicking of different ones, but I would say that one of the things that I haven't mentioned in the description of these nutrient deficiencies, that I haven't mentioned circular spots. So a lot of the typical diseases are going to have individual spots somewhere on the leaf, and so if you see individual spots or a section of a leaf that is affected or multiple spots on it, I would, chances are, lean towards that not being a nutrient deficiency, because the only thing that I've discussed here would be more burning around the edges of the leaves, but not individual spots. I think where you tend to get one more step that's necessary is identifying some of the viruses from a nutritional problem, because the viruses are internal and can look very similar to some of the nutrient deficiencies. So back to the question, how would you determine the difference there? If in the end you haven't been able to get that answer, I think now with the advent of being able to share pictures, I find that that's a very effective way. If Erin gets a question and she's not really sure and she can send Bob a picture, then we may be able to get a first guess at those kinds of things. But ultimately, I would say it comes down to sending it off. You can get a diagnostic if you think it's a virus, or send it off for leaf analysis if you think it's a nutritional problem. But there are some viruses that look very similar to some of these nutrient deficiencies that I've discussed. But I speak for most of the agents. I think, that the pictures, oftentimes we can get a pretty good guess at it, and we seem to be pretty well connected to try to help with those photographs.
Sure. So last question, and then I did put my email on there. If you have further questions, like Bob mentioned, you can always email myself, or if you have a local extension agent, if we can't answer it, we will get it to Bob for you. So the last question or comment is, they noted that their well water has a pH of almost 8. Maybe that would affect plant nutrition.
Yeah. Well, yep. And here at our research center in Live Oak, our pH of the water here will range from 7.8 to 8.2. So it doesn't necessarily mean it's a bad thing. It means that chances are it's really high in calcium. That calcium is available, so it's going to be a good thing from that standpoint. But what it means is that every time you irrigate, you're almost, it's like a mini liming event. And so oftentimes if you have a high pH water, you may hardly ever need to lime. So if you have a high pH water and you also lime, you're going to be probably asking for trouble pretty quickly there, because the pH of that water is going to continue to modify the soil. Where it becomes a problem in particular is if you have an acid-loving plant and you're irrigating azaleas, blueberries, camellias, things like that that are acid-loving, and you're driving the pH up without modifying it with acid-loving fertilizers, then certainly that would be an instance where I have been called out or seen those situations. So I wouldn't say it's all bad, because essentially all of the water that we're irrigating in the Suwannee Valley is going to be a pH about that same level. So the main caution there is that you do not want to lime unless the soil test calls for it. So soil testing is really important. And I grew up on the Eastern Shore of Maryland, and liming was more typical there. But down here, it might be several years before we need to go back in with lime, where we have a lot of irrigation that would be done in that particular area.
Perfect. And I did just post the the plant pathology diagnostic center link, and then also the link to the soil testing, which is the place that does tissue testing as well. So there's a link for both of those. Okay. If nobody has any other, like I said, email us if you do. And we really appreciate Bob taking his time today to speak with us about plant nutrition. And we'll see everybody next time.
All right. Thanks for the opportunity, Aaron. Bye-bye.